Hey Salem, welcome to this month's edition of Building Buzz. You can see the building going up behind me. We've got 3 floors and most of the roof poured. This Thursday they'll finish pouring the roof, and we really have a beautiful building going here. Now with us today I have the building executive, the project executive, Matt Braun from J.E. Dunn. And Matt, we've talked in previous Building Buzzes about what shear walls do for the building, but this building also has post-tension concrete, which is something most of our viewers haven't run into before. So what is post-tension concrete? What does it do for the building?
I'm glad you asked. So post-tension concrete is a selection that is undertaken by the engineer on how to reinforce the slabs. There's a few different ways of doing it. You can put concrete onto steel. You can put concrete into thicker cross sections with lots of rebar, or you can do what's called a post-tension cable. That cable is actually, they're called tendons. And if you look at the horizontal formwork, before we actually put the concrete on, you'll see all sorts of things laid out on that deck. Among them are some long blue tendons. Those are the sleeves that the steel cables go into. And what they do is they put the concrete on top of what you see on that formwork, and they let it cure a little bit. And at one end, it's anchored in, dead end. On the other, they've got a live, and they actually will take a tensioning wrench, and they will take the cable that's in there and stretch it. And 100 feet, it might be even 8 inches of stretch that comes, and it actually pulls that whole concrete assembly together and makes it stiffer. I brought a little show and tell.
I wondered why you gave me this.
Yeah, well, one of the things that you can think of is if you have a load on concrete, it wants to be a little bit weak, right? Mm-hmm. But if you actually put a tendon through it, similar to how this fishing line goes through the wood, and put it under stress, you pull it, then it actually comes back up. So it's very similar. So you've got now an assembly that's stronger than it would otherwise be. What that translates to is less concrete, so it's actually less expensive, and you can go further spans between columns. So when you go into the building, it's going to feel really open because the 30-foot plus spans that are in between the columns, and nice thin profile of the concrete deck, and also less rebar. So you've got the same principle here. And this, the tension, instead of being a wrench or a nut on the end of those strands, they actually have has a spring in the bottom. But it's the same idea. You put it into tension and it stands up. So whenever I see one of these toys, I think of PT cables.
Well, that's cool. That's a great explanation. Also, I like the fact fewer columns means we actually have more usable floor space in the building.
Yes, so it's a more efficient design.
But it also seems like if you're putting all those cables in that concrete, then you don't want to drill into the concrete. So how are we hanging all the heating ducts and all that kind of stuff?
Great question there too. I have another show and tell. We call these bangers. Okay. So on that same deck we talked about before the concrete's placed in, they have these devices here. You can see it's 3 nails and a plate that'll hammer that in, and they go in and they actually mark it out. So I think a few Building Buzzes ago they showed the electronic layout for where everything goes. So they go through and they shoot the spots, and then a crew comes through with a banger and they actually put this into a large gun, as it's called, and they slide it up in there and they push this down, and the banger actually then goes in. These 3 nails go into the formwork, and it sits there and the concrete covers it. And you'll see on the bottom there's something to keep it sealed. Then they strip the formwork out and they can actually remove this, and there's a place for you to put a threaded rod into there. Okay. So up in the top you can see there's some threads. They put it up in there, and now they can actually hang a rod and some strut, and they can run all their stuff through there. So it requires a lot of pre-planning because you want to know where to put these. The last thing, like you pointed out, that you ever want to do is actually go in and start drilling into where you might have tendons.
Yeah.
So this is a way of ensuring that you minimize or eliminate altogether any drilling into that slab after we are done installing it.
So that's a really cool thing, but that's a lot of pre-planning, a lot of coordination between all different kinds of tradespeople. So it really is incumbent upon you guys to manage all of these different folks that are on the site. to make sure that we have a great building and a safe and secure building. So
Yeah, I think this shows up what we see. This is kind of one of the last steps to what we've been talking about so far. I know last month you talked about BIM and going through the total station and doing the layout. Well, this is the actual device that they put into that slab, down to a quarter inch or less of where exactly that thing needs to go. So this is kind of that last piece that ties all that pre-planning, the coordination with all the subcontractors and engineers, so that we come in and build it one time.
now, have you ever built a post-tension building before?
Yeah, we have. J.E. Dunn has, and I've been a part of these buildings, and certainly our superintendent has as well. It's actually pretty common in commercial construction for this to be used as a methodology, but it is really important to understand what you're doing and to hire good vendors or to hire a good crew to come in and actually place it. It requires a lot of thought and knowledge and expertise on how to tension those properly.
Yeah, so great teamwork, great planning, and we end up with a beautiful building. So one of the things we're celebrating this week is a milestone in this building. So the roof is poured, and so what we're celebrating is the topping out of the building. So tell us a little bit about what the topping out ceremony is.
Well, it's an old tradition going back to when buildings were first built by steel. The iron workers would take that last beam and set it up with the crane and put it in place, and usually hang a Christmas tree or similar after it on it. It's kind of marking the phase of structural erection being complete. So we still do it today in the industry, even when we don't use steel.
Yeah.
So our big celebration today, Friday, is going to be the topping out ceremony, where we get done and mark a significant milestone in the passage of the structural component of the project out and all the other trades coming back in.
That's awesome. That's a great tradition. Thank you, Matt.
Thank you.
I appreciate it.
It's been our pleasure and my personal pleasure to be here working with you guys.
Good. We are so excited about this.